In this video, I introduce a large language model code debugger. Humans debug programs by setting breakpoints and selectively give them runtime execution information. Similarly, large language model debugger is a debugging framework that uses large language models to refine the generated programs with the runtime execution information. LDB segments a program into a sequence of basic blocks and tracks the values of intermediate variables after each block throughout runtime execution, which allows a large language model to concentrate on small code segments within the overall execution flow. As shown here, this is the runtime execution information. This control flow graph is generated from the seed program, and this breakpoint in program, and this runtime state. A large language model is prompted with a task description to generate a seed program. If it fails the test, LDB starts to debug the program block by block by feeding the field visible test case into the seed program, and collects runtime execution information such as execution trees and runtime variable values. LDB queries a large language model to verify the correctness of basic blocks step by step via aligning the execution results with the task description. Using blockwise runtime execution and the task description, LDB queries the large language model again to detect the buggy blocks and regenerate the program. LDB repeats these steps iteratively until the new solution passes all the visible tests, as shown here. This is the step to generate the seed program, and this is step 1, this step 2, step 4, and step 4. Each basic block has only one entry point and one exit. The intermediate state after the first I blocks is defined as a triplet, where V I-1 is entry state, and BI is a current code block to execute, and VI is an actual execution result. To debug the block, the intermediate states are integrated into prompts and query large language model to verify whether the basic blocks align with the intended semantics in the task description. The large language model vertex correctness DI, true or false, of each block in the execution trees and elaborates the explanation. If the large language model detects any buggy code block, LDB includes the message in the debugging response. The runtime execution information helps accurately localize buggy code blocks, allowing large language models to concentrate on these blocks during the regeneration process. In regeneration, LDB collects the debugging vertex and explanations and incorporates them along with the task description into the prompt. Then LDB queries the large language model again to generate the refined program. LDB iteratively runs providing debugging and regeneration until the refined program passes all the visible test cases. For more details, please check with these references. Thank you. Bye.